Okay, kia ora koutou. Hopefully everyone can hear me. So this is the first of 3 successive talks on reintroduction, and suitably enough, Kevin is out in the field preparing for reintroduction at the moment, so he's made me give his talk. But there is a little picture of him here on the bottom left, so you know who to blame for this particular talk. So the title is Successful Translocations, Inferences from Post-Release Modeling. Just start, if I can get the clicker to work. I'm having, for some reason, I'm not getting my slides to advance at the moment.
Just do a double click there, Doug.
Okay, that worked. Okay.
Yeah.
Okay, the usual options didn't work. Okay, so this is just showing some media coverage. This is what most people know about reintroductions as animals arriving at the release sites and being released happily. Okay? And of course, it is a bit more complicated than that. It's actually quite a stressful thing for the animals. It's quite stressful for, and now I've gone the wrong way. Okay, fantastic, now it's working. Okay, so one of the first things Kevin wanted to do was, by way of advertisement, to draw attention to a review paper that's coming out hopefully soon in New Zealand Journal of Ecology, where he's discussed a range of issues around conservation translocations in Aotearoa, New Zealand, and especially around predator control. And one of the issues is just, or really a key issue, is around this issue of what's a successful translocation. And one point that's addressed quite a bit in the paper, but don't really have time to go into here, is that defining success is not straightforward, and nor should it be. And the bottom line is it depends on your objectives, translocations. There are often several objectives and they differ between programs. Having said that, the key objective, or a key objective, is always to establish a population, and the idea is that we hope that population is going to persist for decades, if not hundreds or thousands of years. So the rest of this talk really focuses on this idea of success, and the immediate point is what actually limits reintroductions from being successful. And of course, there's a whole range of things. In the context of this program, we're zeroing in on 2 things that we think are particularly important. One of these is introduce pests, which we've talked about a lot over this session. And the second one, which Zoe's going to talk about, is dispersal. And in this case, basically, we think of dispersal as kind of an enemy, specifically dealing with birds, which can easily disperse out of managed areas, and that can be a limitation for whether our populations persist or not. Zoe will deal with that. For the rest of this talk, me or Kevin is going to talk more about pests, and an idea that's been brought up, I guess, at the start, particularly by John Ennis, is this idea of pest thresholds, or how many pests, or what pest density do we need to get down to allow native populations to persist. And the surprising thing for many people is that while we've done quite a bit of research on this, it's largely unknown for most native species and most pests. And it is critical, of course, for the issue of translocation success. It's also critical for optimal allocation of resources. For example, how much do you invest in pest control at various sites, and then that flows on to the whole predator-free program. So the next part of the talk is really to go into a specific case study. And we've done quite a lot of work looking at rats as a problem, and I'll talk about that later. But here, Kevin wanted to draw your attention to some work we've been doing looking at impacts of stoat and cat incursion at quite low numbers, and what effects that has or hasn't had on some translocations, and what implications that has for the future. So in this case, we're talking specifically about stoats and cats, and specifically about Tafaranui Open Sanctuary, which is one of the peninsular sanctuaries, and this is just off near Warkworth, up north of Auckland. And being a peninsular site, it has a fence across the base of the peninsula. It's a bit of a leaky fence, of course, because peninsular sites around the fences around the edges are not at all foolproof, so things do get in. But this has worked well enough that the team there have been able to translocate 7 different bird species, lizard species, a fish species, and also quite a few birds have found their own way in established populations. Okay, so pest control and monitoring. So the fence was put up in 2004, and there was initial aerial eradication to get rid of the invasive mammals. That there were 10 different species of mammals at the time, 8 of which were successfully removed. Mice and small number of rabbits persist. And there's a big ongoing monitoring program with all the usual predator traps, bait stations, wax tags, etc., to try to pick up incursions of the various species, including the things that were eradicated, particularly rats, cats, and stoats. And this, as well as the monitoring, of course, it involves a kind of incursion operations to try and mop this up when animals do arrive. And this graph is showing data from basically from 2004 onwards, the numbers of stoats and cats that have been caught each year. You can see for the first 13 years of the program, there were occasional 1 or 2 stoats or cats that got in, and those were mopped up. Okay, but things kind of changed in 2017. So you see there's a period of 4 years there where there was a continuous presence of small number of stoats. And then the last couple of years, there's been quite a big upsurge in the number of cats that have been caught, suggests that there's a continuous cat presence at the moment. So the question for the translocations is what effect has that had on the bird species that have been brought in? And here I'm just going to talk about the passerines, partly just because I've got the best data. So 3 species to talk about, Popocatia and Totoi, which were both reintroduced in 2007. Those are 2 species that are extant on the mainland in areas outside predator fences, but they are both quite pest sensitive. The third one is Tiaki, which were reintroduced in 2012, are extinct on the mainland except out in predator sanctuaries, and they're highly pest sensitive. And also briefly mention hihi, which are another very pest sensitive species. There was a reintroduction plan for 2020, which of course we've held off on because of the stoat and cat incursions. Monitoring, Popocatia is fairly basic monitoring, which is just 5-minute and line counts, transect counts. Most of those are those birds are unbanded. Totoi is kind of the opposite. It is the gold standard kind of monitoring, and that's mostly been done or led by Tim Lovegrove, which has involved not only doing surveys, but doing intensive monitoring over the breeding season to actually measure how many fledglings each pair manages to have, and then color band those fledglings in the nest so the population remains mostly color banded. Tiaki is somewhere in between. The population is sort of partially color banded. Kevin's done quite a few surveys, and there's enough of them color banded to do a mark release, capture mark release sort of analysis there. So just going on to the data, Popocatia, all we've got is data on the trends from counts. Okay, big error bars around it. There's lots of issues associated with these sort of data, but it is very consistent with just logistic growth and reaching a carrying capacity as shown by that fitted blue line there. Totoi, I remember, have the best data. These data are quite interesting. You'll see that if you look at the trend, and this is the total number of breeding adults each year from 2007 up to 2016, it looks like it's going up, reaching a carrying capacity, and perhaps then falling after the stoats arrived. If you look at the vital rates, you get a more complicated picture. So this is the lambda, or finite rate of increase. That's basically how quickly the population is growing. The bottom line is lambda needs to be above 1 for population to increase. If it's below 1, if it's down here, it's declining. The point here is that those lambda values are all over the place between years. And that, if you look at the bottom down here, is driven by annual variation in juvenile survival, which is also all over the place. So stoats may be having a role there, but it could also just be because it's varying, say, with climatic conditions from year to year. Tiaki has a different story again. You see there's kind of a linear trend in abundance from 2012 up to 2017. The linear aspect is relevant. And then there's a big crash, and then it's kind of settling down. So that crash, of course, is occurring from 2017 onwards with this period where there's stoats and cats in Tafaranui. Okay, so what's going on there? If you look at the lambdas for Tiaki, you get a completely different story. Again, here's where lambda's 1, and what we're getting is a gradual decline. So this is the signature of a classic density-dependent response. This is what we see in Tiaki reintroduced into small sanctuaries. It's driven again by this decline in annual recruitment. So what seems to be happening with the Tiaki is that they've just got to the stage where they're probably approaching carrying capacity, and then the stoats basically arrived at this point, and there's quite a dramatic crash there. And what we're possibly seeing in here now, as the density went down, is we're getting some what we call density dependent compensation. And in other words, the Tiaki are able to breed a little bit faster when the numbers are knocked down, and that's possibly enabling them to hang on. And we've got some similar things going on in terms of the survival down here. But getting down to summing up the different population impacts for these different species, Popocatia, perhaps not surprisingly, given the kind of a canopy bird, is that there's no obvious evidence of stoats or cats affecting their population. Totoi, it is possible. I know personally that stoats can take juvenile totoi, so that could explain part of the pattern we're seeing, but it could also simply be driven by random annual variation in juvenile survival. On the other hand, with Tiaki, we do kind of believe that there's good evidence that stoats are causing that dramatic decline just as the population reach carrying capacity. There may be some density dependent compensation going on, and possibly cats are doing something in there as well. Tiaki, of course, the translocation was postponed. So just summing up in terms of management implications, I guess the main point Kevin wanted to emphasize is that even very low numbers of stoats and cats can cause dramatic declines in species that are quite sensitive. And as well as Tiaki, he's listed some candidate species, hihi, red-crowned kakariki, snipe, kakapo, and possibly some seabirds. And just wanted to make the point, the prospects for reintroducing these species to unfenced mainland sites are probably grim without being fairly confident of complete eradication. Now, if we expand this to looking at other types of native species and other types of predators, then we're going to need to start thinking about things like responses of things like herpetofauna and vertebrates that might be particularly sensitive to mice. So might also have difficulties unless mice can actually be totally eradicated, which is, of course, a much bigger problem. And I guess the final point in terms of what we're contributing here is just emphasize that monitoring data when they're available, they do allow us to estimate impacts of incursions and start to get at this idea of what are thresholds that different species can allow. But at the same time, it is quite complicated by effects such as density dependence and environmental stochasticity. Okay, that's it for Kevin's talk. So I'll take questions if there's any.
Cool, that was very interesting, Doug. And yeah, thank you to Kevin as well. There's at the moment no questions yet from the audience. So I'll take the chance and jump in. Well, I was quite curious with the sanctuary being so close to Auckland, one of the biggest cities, if those cats are actually feral cats, or are they at times almost escaped domestic cats that make it into the sanctuary?
Yeah, this is if Matt Maitland is I know is here, if he wants to respond in the chat to questions like that. I imagine it's a mixture, you know, of people's moggies actually getting in. There's probably also, you know, feral cats cruising around, but I don't actually have the answer to that. So
Yeah, actually, I just saw that Matt has written a comment for Doug from Tafaranui Sanctuary Manager. The graph of incursions cannot assume equal detection effort. Technology, mostly cameras and dogs, has massively improved our confidence in detecting invaders. How many invaders we missed in the first 10 to 13 years is unknown. Despite that, we are confident that the observed increase in invaders is real. So yeah, pretty much saying that definitely they've detected more with time. Invaders do seem to be getting harder to remove, or maybe those that may have evaded detection in early days show they are just as likely to evade control tools. And there's another question, Doug, I might have missed it, but is the peninsula rat-free?
The peninsula is, well, not the whole peninsula, but within the fence, it is normally rat-free. Again, this could be a question for Matt, but I believe there are occasional rat incursions as well, which you know, I think the team has done fairly successful in terms of detecting and mopping up.
Cool. And a question from John Innes. Doug, how do you think Popokatea escaped stoat predation at nests?
Yeah, that is a very good question, and I don't actually know whether stoats are, whether there's any other information specifically about Popokatea and stoats. I don't know of anyone ever putting cameras on nests or doing anything like that.
Yeah, cool.
It could be. I mean, it could be they could nest in places that you know, far out on branches and things where stoats are less likely to get them. But somebody else might have a better idea on that one.
Cool. Yeah, I mean, definitely from our own work, it was amazing that Popokatea, despite being translocated quite a lot, there wasn't actually that much information on their breeding biology,
Yeah,
which
yeah.
surprised me.
Well, as you would know from your recent experience, yeah. I mean, some species, their breeding biology is not easy, and Popokatea I think is one of them.
Yeah, cool. I think I might leave it here.